That's what I was trying to do and I accidentally closed the screen the first time. Okay, welcome, Wes and Will. And let's get started. Today, we're going to talk about chemistry. It's a new word, and it's a study of what things are made of, what things can do, and how they can change. So we've got a special word here. It's called chemistry. So when we're talking about water, we can learn about the chemistry of water, what water is made of, what it can do, and how it can change. When we're talking about sugar, we can think about what sugar is made of, what it can do, and how it can change. Okay? So that's an example of chemistry. All right, so let me start off with a question. Oh, hi, I see a few people. Guy and Jasper, welcome, welcome. If you're able to, I'm glad you were able to turn on your camera. Wes and Will would usually turn on the camera, but it's just not working.
Are we late?
Okay, just a few minutes late. You're doing okay. Hang in there. We just started. We're learning about chemistry today, which is a study of what things are made of, what they can do, and how they can change. Okay. So let me ask you guys a question. Let me ask everybody a question. Has anybody ever eaten ice cream?
I have.
Yeah. Yes.
Yeah.
I'm eating it right now. I'm eating it right now.
Awesome.
Yeah.
So, question for you. What is in the ice cream?
Milk. Like milk.
Milk, sugar, and other stuff.
Milk,
like
sugar.
Like
Anything else?
cream.
Milk and sugar, maybe water. How about that? Is that true? Water too? Hello.
Probably like fruit or something to make like the flavor.
Yeah. Yeah. There we go. So there's a lot of stuff in ice cream. Excuse me, I keep clearing my throat. Let's learn a little bit how that's done, right? But before we can learn about how that's done, let's learn a little bit about one of the things we know is in ice cream, which is water. So let's look at the picture of water that we have here, because we're going to talk about the chemistry of water. Let's think about this. This water, is water hard? Or is it soft?
It's both.
Probably like hard. Wait, no, soft.
Hard? Well, in this picture, is the water in this picture hard or soft? How about that?
It's both.
Hard.
The water in the picture is hard. Okay. Let me ask you this. Is this a liquid or is it a solid or a gas?
It's a liquid.
It's a liquid. Okay. Liquid is something that, let's say, for example, when I want a cup of water, I pour it into my cup, right? So does the liquid take the shape of my cup? It just fills the cup, right? Yes?
Yeah. Yeah.
And if I were to take that same cup of water and pour it into a different cup, would it still have the shape of the first cup or would it take the shape of the new cup?
No. It would probably take the shape of the new cup.
Exactly, because it's a liquid. So water in a liquid form takes the shape of the container it's in, right? The cup it's in. What would happen if I would say, hey, can I make this water a solid? What would that be?
Ice.
Yes, that would be ice. So ice and water, they are the same thing. The difference is ice is solid water. Is that true?
Yes. By the way,
Yeah.
if you want to know, snow is ice.
I didn't hear that. What did you say?
Oh, forget it.
Okay. So if solid water is ice, then can water be something in the air? Is that possible? Yes, Wes and Will?
Yes, it can become steam. Yeah.
It can become steam, which is water in a gas form. Okay, that's great. So now we know that there's air around us because there's gas, but we can't see it, but we know it's around us, right? So water can go through all three things. It can become a solid, it can become a liquid, and it can become a gas. And the gas is called steam, like you said. So these are called phase changes. That word phase, P-H-A-S-E, phase changes. So when the matter or the thing moves from one form to another, so when something moves from being a solid to a liquid to a gas, or if it goes the other way, when it moves from being a gas to a liquid to a solid, that's called a phase change. So with water, when ice is a solid, when it melts, it becomes a liquid, which is, we heat that up, we get steam, right? And this is interesting because it's actually used in a lot of things in cooking. We use phase changes. So let's talk about what we know about water, but in a little bit more detail. Like I just said, when ice warms up, it becomes water. When water becomes really hot, we get steam. That we know. So here's another thing. Just like when your parents take your temperature when you have a fever, these phase changes happen at a certain temperature. Did you know that? Yes?
Yeah.
Yes, awesome. So with that in mind, let's talk about temperature real quick. So we know ice is cold, and when it gets warmer than 0 degrees Celsius in temperature, it becomes water. And when the water gets hotter than 100 degrees Celsius, it becomes steam. And so we can say this from the other way too. We can say the steam, when it becomes colder than 0 degrees Celsius, it becomes back down to water. And when the water gets colder than 0 degrees Celsius, it goes back down to being ice. Okay? And this is important because this will help us understand one more thing about our houses, which is we have a fridge at home. And the reason things stay cold in your freezer is because it's colder than 0 degrees Celsius in there, which means what for your ice?
It'll stay frozen.
Yeah.
It'll stay frozen, exactly, because it is colder than 0 degrees Celsius. That's right. And let's look at our fridge. Is it colder than 0 degrees Celsius, or is it hotter than 0 degrees Celsius for the fridge part?
Hotter.
It's hotter. So it doesn't freeze, but it still stays cold, right? Oh, hi, Tiago.
Yeah.
Thank you for joining us. Welcome. So that's how that works. But let me add one more element to this. What happens if I add some sugar to a glass of water and stir it? What happens? What if I add some sugar to water and stir it? What happens? What do I see?
It becomes sugar water.
Okay, it becomes sugar water. Can I see the bits of sugar floating in the water?
I'm just gonna do this right now so I can
Can you see the bits of sugar floating in the water when you stir it?
see. My mom didn't let me.
So you think you can, Wes? Okay, so let me ask you, since you guys probably haven't done this before, you can experiment with this when you get a chance. Take a spoonful of sugar, a cup of water, and stir in the sugar. And then tell me what you see. What you'll see is after a while, the sugar is gone from your spoon and the water looks clear again. Has anybody ever seen that before? Yes, there's a word for that. The sugar has dissolved. That means it's mixed in completely. It's still there, but you just can't see it. It's just amongst all the water particles in there. So now we have sugar water in our cup, right? Because we added sugar and it's sweet water. So what happens if I try to make this sweet water and put it in the freezer? What do you think will happen?
You get sugar ice made?
Sugar ice? Hi, Wes. Yes, what are you saying?
You'll be able to see the sugar again.
You think you'll be able to see the sugar again? Okay, that's one idea. That's what. Do you have another idea? Anybody else? What happens if I put my sugar water in the freezer?
sugar water.
You're making sugar water. Okay. What do you think will happen if you put your sugar water in the freezer? Anybody? Anybody else? Nope. Okay. Wes's theory was you'd be able to see the sugar in the water. I'll give you another clue. So let's learn a little bit about what happens when sugar is added and dissolved into your water. So when we add water, and we put it in our freezer, let's look at this picture again. Do you notice any difference between this one and our previous one? What do you notice about the difference in the phase changes here? Yes, Will.
You mean like the ice and the hot water?
Yeah, what do you notice about the difference?
The hot water isn't frozen and it's like a different color, and the ice is frozen and it's like clear.
Actually,
Oh, okay. Well, there's a little bit of confusion. Let me be more clear.
the water isn't really colored, it's just the cup.
Yeah, it's just the cup. But let me show you this. It was this picture. Here we go. So I said if we had regular water, this is what temperature the phase changes take place. So pay attention to the degrees for the temperature. Okay? For regular water, when it becomes super and colder than 0 degrees Celsius, it turns into ice. What happens if I make my sugar water and then put it into the freezer? If I make my sugar water and put it in the freezer, it has to get even colder than 0 degrees before it turns into ice. So it takes it before it turns to ice. Does that make sense? So adding sugar to my water changes what happens to just the water. The water doesn't freeze as easily. It gets frozen much later. So why does this matter? Can anybody think about what sugar would be like, sugar water would be like in the freezer? Can you think of any examples? Yes, Will?
I think it might be like
Oh, I can't hear you.
wait, I think it might be like like creamy sort of.
Hang on. I think, you know what, my headphones just stopped working, so let me take them off. It's probably not you.
Go ahead, Will. You were saying something?
Hello. I think that it might be like soft.
You think it might be soft? Okay. Can you think of an idea of what an example of sugar water in your freezer is like? This is sort of a sneaky clue. We kind of mentioned it in the beginning. Yes, Guy or Jasper, one of you?
Like the sugar is like if you look at it up close, it kind of looks like well, I don't know, like it's probably like the sugar like absorbing like the coldness from the water or something.
Okay, that's one theory, but I'll give you an example of what sugar water would be like in your fridge or freezer. Do you have any ice cream in your freezer? That's what sugar water would be like in your freezer. It would be like that, right? Ice cream is a combination of milk and sugar and water. So if we don't have milk in it, it would be kind of like a popsicle, right? So that's one example of sugar water in your freezer. So popsicles, sorbets, ice cream, they all use this idea of what happens when you add sugar to water and then try to freeze it. What we know happens is it has to get much colder than 0 degrees Celsius before it freezes. So when you take ice cream from the fridge, what's the thing you try to do? You get an ice cream scoop and you try to do what? You try to scoop it, right? So let's learn a little bit about that. Let me go to my next slide. So we have a chef here who did a little experiment with making ice cream to demonstrate this concept. Let's go through the concept again, just so we understand. We know water goes through phase changes, right? Water can be a liquid, which is the water in my cup. We know water can be a gas, which is steam when I start boiling water. We know water can be a solid, which is ice. We know that. And then we learned what happens if I add sugar to my water and then I watch it change. It changes how cold it needs to be before it freezes. So let's watch this experiment that this chef did about water and sugar. Okay, are you ready? When I start playing the video, give me a thumbs up if you're able to hear it, okay?
Okay, good. Just checking. Which is the reason that you have to buy candy thermometers. Joanne, I don't think needs a candy.
Oh, hang on. I'm sorry. It didn't start at the right position. Let me get it to the right position. It's right here. Let me get out of that slide so I can help you out with that. I'm gonna show you slide 18.
Increases, which makes the boiling point increase.
1747. Okay, let's start at that.
Dangerous for me to see because
inside the cookie, and it helps it last longer. So
Here we go.
okay, so the people who said popsicle, sorbet, and milkshakes. This is a really interesting part about sugar that I didn't know from a science level. I just knew from an operational level that when I used to make sorbets and ice creams, if I had something that didn't have a lot of sugar, it was really, really icy. And if I had something in which I had mismeasured and I put too much sugar, it was really soupy. And I could never really figure out why. I just made sure that I followed the recipe so that wouldn't happen. But in studying more about the role of sugar and what it does to desserts, sugar actually depresses the freezing point of a liquid. So if we take ice and we put it in the freezer, you get an ice cube, right? It's going to freeze at 0 degrees Celsius, 32 degrees Fahrenheit. If you add some sugar to that, what it does is that it means that that sugar water won't freeze right at 0 degrees Celsius, but it might be a little bit lower. And so if you have a freezer that's at 0 degrees Celsius, then that sugar water that you have won't freeze solid. So we use this to our advantage when we're making frozen desserts. So when you make a popsicle or sorbet or milkshake, you need the sugar to make it taste good and to make it sweet, but you also need the sugar to make it actually scoopable so that you can eat it. So it's not like sucking on an ice cube. So this is a video. Jess made 5 versions of grapefruit sorbet. This is just grapefruit and water. There's no sugar. This version has a half a cup of sugar. And she wanted me to explain that she's holding the iPhone with one hand and she's trying, which is why it looks like it's really awkward, because we were watching and I was like, why are you looking so weird? And she said, it's because I'm trying to hold the iPhone at the same time. This is version 3, 1 cup of sugar. This is the actual recipe. You can see you can actually scoop into it. This is version 4, 1.5 cups of sugar. And you can see that you can scoop into it, and you can see that it's actually kind of melted because it's not quite frozen. And then finally, this is 2 cups of sugar. This is twice the amount of sugar that you should have in this recipe, and it's practically soup. You can see it's like really syrupy, and she doesn't even have to be so stiff anymore. So that's what sugar does to popsicles, sorbet, and milkshakes. That's not only does it add the sweetness, but it also allows for a nice texture so that you can eat it and it's
Can you hear me? Okay, yes. So what did you notice in her experiment?
That on the video we were watching in the other video.
Yes. Did anybody notice anything about the experiment that she did? Yes, Wes and Will. Yes.
I saw that the more sugar she got, the more milky and like syrupy it got. And also, I want to say hi to Guy and Jasper.
Okay. So that's right. The more sugar she added, the more liquidy the ice cream got, right? But the less sugar she added, it was like more rock hard, like a cube of ice, but with flavoring in it. Isn't that interesting? So this is kind of what the idea that they use when they make ice cream. They use this idea to add the correct amount of sugar so that your ice cream is scoopable with an ice cream scoop and it's not rock hard. But if they add too much, then it'll be like all liquidy in your ice cream jar, and nobody wants a liquidy ice cream. So they kind of use this science, this chemistry, to make the correct kind of ice cream. Isn't that interesting? So let's look at one more kind of sugar that you've probably all seen, but you haven't thought about it in a chemistry perspective before. Let's go to the next slide. Let's see if I can get this. Has anybody had this? What is this picture? What is the person eating?
Cotton candy.
Cotton
Yes,
candy.
I have. And I have had this.
I love it.
Everybody has had cotton candy. Ansley, Jane, Tiago, have you guys had cotton candy? Do you like it?
Yes.
What is cotton candy made of? Anybody?
Sugar.
Sugar.
Yes,
Sugar.
Is there anything else in cotton candy? Anybody else? Anything else? Any other ingredients in cotton candy?
I don't know.
Like some.
Well, they have.
Maybe there's like fruit juice or like something that like makes it like flavor or something.
Tiago, what do you think?
I know. I've seen the making of cotton candy. Don't they use like a type of like flavored milk?
No, actually, let's find out more. Do you want to find out about how cotton candy is made? It's very
Yes,
interesting.
please.
It's like almost 100% sugar. But
Yeah.
they're using the science of what we just learned. So let me just recap the science of what we learned so that we can understand exactly how cotton candy is made. So I'm just gonna go back to a certain slide to help us out. Right, so give me a second here. So we learned in the beginning, we learned water goes through phase changes, right? Water goes from solid to a liquid to a gas, or it can also go backwards from a gas to a liquid to a solid. And each of these is called a phase change, where it's moving from one transition to another, okay? And we know in the case of water, when we have a cup of water, if we make it very cold, we get a solid. If we have a cup of water and make it really hot, we get a gas. We know that. And we know what temperature this happens. So this is still true for a lot of materials. So for the same thing, I don't have the temperatures that you would use, but sugar, just regular sugar, can also go through phase changes. Sugar can be a solid. Is sugar a solid, liquid, or a gas? Will or Wes?
So a solid.
Solid, right? Because it's a little bits and pieces on a spoon, right? So that is a solid. If we were to melt sugar, it would become a liquid. Could sugar be a gas? Usually you don't see that because what happens is it gets burned really easily and all you get left is like burnt sugar. It smells really, really bad. Don't melt sugar. It smells bad when you burn it. If you melt it correctly, you get caramel. But if you melt it wrong, you'll get burned sugar. I don't recommend you do it at home. But anyway, sugar can change from solid to liquid. That one we know. It's true. Just like water can change from solid to liquid. So let's see what happens when we talk about cotton candy. All right. So for cotton candy, we're going to think about the phase changes. Let's go to the next slide and see if this video works correctly like intended.
I've seen the video.
When sugar crystals are put.
If you've seen it, then hang on and let the other people who haven't seen it yet watch it, okay? Let me get this to play. Correct. Okay, it's working.
When sugar crystals are put into a cotton candy machine, they start as solid crystals. These sugar crystals usually have food coloring and flavoring added to them, so they'll be extra colorful and tasty. Next, the cotton candy machine starts to heat up, and that heat begins to melt the sugar, changing the sugar from solid crystals into something new. What state do you think the sugar will melt into, Squeaks? That's right. When solid sugar melts, it melts into liquid sugar. While the sugar is a liquid, it can change shape much more easily. That means the machine can stretch the liquid sugar into long, thin lines. The cotton candy machine has a lot of teeny tiny holes inside for the liquid sugar to go through. Little drips of liquid sugar go through as the machine spins, and when they fling into the big empty space in the middle, they cool down really quickly and change back into solid sugar. The liquid sugar can turn back into a solid as it cools down, just like it melted when it got hot, but it looks a bit different now. Yeah, just like threads of cotton candy. When the liquid sugar cools back into a solid, it keeps the long, thin shape that allowed it to go through the cotton candy machine holes instead of turning back into the larger, hard crystals of plain sugar. Those little sugar threads are rolled up into a big, fluffy puff that we recognize as cotton candy. The sugar changes a lot when it's heated up and cooled down. It went from a solid crystal to liquid to a thin, fluffy
To a thin, fluffy solid. That's how cotton candy is made. So cotton candy is just sugar and food coloring. They melt it and they spin it really fast. So you know when you have a spoonful of water and you spin it, you see water spraying everywhere. So they basically spraying the liquid sugar everywhere, and then it dries really fast into a string. And then they spin that string onto a stick or a paper cone, and that's cotton candy. It's sugar, 100% sugar and food coloring. That's it. But it tastes delicious because it's sugar. Okay, so did you guys understand what happened there? We went through a phase change, right? It was a solid sugar, and it phase changed and heated up and melted into a liquid sugar, and then
Did
it
you know
cooled down
that-
back into a solid. Okay, was that a question? Yes.
Did you know that cotton candy actually you disappears in your mouth?
It's
It
'cause-
dissolves.
Okay, let's talk about that. It disappears in your mouth. So somebody, I think Guy, you took a spoonful of sugar and you stirred it into water. What happened?
It would like dissolve in your
It
mouth.
dissolved. It disappeared into the water.
Like if
But
it
what- is your
touches
tongue
any
wet or is it dry?
what?
Is your tongue wet or dry?
It's dry. Wait. Yeah, it's dry.
No, it's not. Touch your
Oh,
tongue.
yeah,
Is your tongue wet or
I
dry?
forgot. It's sweat.
Right. So because your tongue is wet, when your cotton candy touches it, what is it doing?
It's dissolving.
It's dissolving on your tongue. So it feels like it disappears. But all that happened is it disappeared, it dissolved into your own saliva, and you went, so much sugar, and you had another bite. That's what's happening.
Whenever cotton candy touches some sort of liquid, it just dissolves.
Exactly. Because it's just sugar, right? So same as you taking a spoonful of sugar and stirring in a cup of water, it's dissolving on your tongue. That's what's happening, because we know cotton candy is like really, really thin strings of sugar, so it doesn't really take much to dissolve. Okay, so that's what's happening with cotton candy. Now, I know we're almost out of time here, so I'm going to give you a fun little experiment you guys can do at your own homes. Probably not tonight because you'll run out of time, but you can do it on your own and think about it. Okay, let me explain the fun experiment. But before I do, does anybody have any questions about anything we learned today? Any questions? Nope. Okay, experiment time. Oh, my slide didn't advance, my bad. Next slide, thank you. Haha. Okay, here's the experiment. It's super simple. I'm going to actually explain it to you, and we'll watch a little bit of the video when the person actually shows the experiment, but I won't show you the answer, okay? So this is what I want you to do. She does it slightly differently in the video, but I'm gonna tell you what would work, and you will see probably a little bit more noticeable results than what's in the video. So you're gonna take 3, and this is very important, 3 plastic cups, not glass, 3 plastic cups of water, like those disposable cups. 3 plastic cups of water, and you're gonna put a little piece of tape and label each cup. Label 1 water, label 1 sugar water, label 1 salt water. Okay, for the one that's labeled sugar water, you're gonna stir in 4 tablespoons of sugar. And then for the one that's labeled salt water, you're gonna stir in 4 tablespoons of salt. And then you can put all 3 cups into your freezer. And you're gonna check once every hour and note the differences between the cups. Okay, and after you check the differences, you're gonna write it down, and then you're gonna put them back into the freezer and check again after 1 hour. And keep going and checking this app every hour until all 3 cups are frozen. Now, I see questions. Yes, Wes and Will.
I know that salt melts ice really fast, so I don't think that's gonna turn to ice like almost at all.
Ah, see, okay. You mentioned a very interesting fact. Salt melts ice really fast. What do you think is happening? There's a clue in what you said that will explain it. I'll go back to the diagram to help you out. Hang on, I'll go back to that page to help you get it. Let's see.
Sugar water is still, your salt water, your sugar water is still.
Okay, can you see the slide?
I mean water.
Okay, you just said salt melts ice real fast. So let me ask you a question. If I put salt on a spoon and stir it into a cup of water, what's gonna happen?
It will probably like not freeze for like 10 billion hours.
No. Just like you took the sugar, you took a tablespoon of sugar and mix it into water, right? If I did that with salt and I took a tablespoon of salt and mix it into water, what will I see? You can do this at home, right in front of you. Hello? Yes, Ensley, you said something?
Evaporate?
It would evaporate? Well, no. I think if you take a spoonful of, if you were able to go get a spoonful of salt and a cup of water and stir it in, what you would probably be able to see really well, especially if the cup is clear, is you will see yourself stirring and stirring and stirring and seeing all the little bits of white for the salt go away. And the word for that, which I think what you were trying to say, is dissolve. You would see it dissolve. It would disappear. It would look like the salt disappeared. And the word we're looking for is dissolve. The salt has dissolved, which means it has mixed in really well. Okay? So if I mixed in really well the salt, I wouldn't be able to see it anymore. So Wes had said earlier, what did Wes say? Say the thing you said about salt and ice, Wes. Repeat yourself. Oh, he disappeared. Did you want to repeat what you said about salt and ice?
Salt melts ice really fast.
Okay, so let's pause and think about that. Salt melts ice really fast. Okay, you're gonna try your experiment. Is it melting your ice?
It's not working right away.
Okay. Well, let's think about it differently, right? Just like I talked about you putting the cotton candy on your tongue. What happens when the cotton candy touches your tongue? What's the word I used? Yes, Wes or Will.
He says he doesn't know.
Oh, that's okay. We said that it kind of disappeared on your tongue, which means it dissolved on the wetness of your tongue, right? So salt can dissolve in water too. So what's happening on the ice is the salt is dissolving on your ice, dissolving into the water on the ice. And then when it does that, it's doing something very similar to sugar. It's changing the phases of the water. Just like sugar, when you add salt to water, it's gonna make it have to get super cold before it starts freezing again. And it's basically changing how long it'll take before it freezes, what temperature it will freeze at. So when you do this experiment I told you about, you're going to notice all of these changes, and you're going to notice the difference between when you had salty water frozen, sugar water frozen, and regular water frozen. But let me just show you that video real quick, and she'll show you a little bit of the changes, but when you do it at home, you're going to see your own and it'll be a lot more clear. So let me just play that video real quick. Let's see if it works. So remember what I said, get 3 plastic cups, fill them with water. Don't fill it to the top, fill it like 3/4 of the way, okay? And then label each cup, label 1 water, label 1 salt water, label 1 sugar water. For the salt water, add 4 tablespoons of salt. For the sugar water, add 4 tablespoons of sugar and stir it in for both. And then put them in the freezer. And then every hour, double check what's happening and then put it back in. Okay, let's watch for a little bit. She does this.
Let's take our 3 cups, and I'm going to use the measuring tools.
So she's labeling her cups. Notice she's using plastic cups. And the reason you don't want to fill your cups to the top is because ice expands, so it's going to fill up to the top of the cup when it freezes. So you want to leave it a little bit more gap from the top of the cup. So don't fill it to the top, okay?
2 of the cups, we're going to make solutions. The first one is salt water solution, and another one sugar water solution. The 3rd cup is just going to be pure water. So now, let's fill each of these cups with water.
See how she leaves a little gap at the top of her cup? You definitely want to do that when you do this experiment at home, okay?
So except for the water, we're going to take 2 of ours. So for the salt solution, I'm going to take a spoon of salt and put it in the salt water solution. This, and then I'm going to stir it well.
So she's stirring to dissolve it.
Dissolve. Next, we're going to take a sugar water mixture, and now we're going to add 1 spoon of sugar to this. And let's also dissolve this. Okay. So now all 3 of the solutions have been made. One is salt water solution, one is sugar water solution, and one is pure water. Now we're going to freeze it, and in a 1 hour interval, we're going to again observe it. So this is already has been 1 hour, and so for our results, this is our water, this is our sugar water, and this is our salt water. So if we look at our water, the pure water, then it's almost icy. But then if we compare this pure water to our sugar solution, or sugar water, then you can see that our sugar solution,
You can see your sugar solution is not the same as the regular water one. Yes, Wes, you had a question.
So yeah, the ice is melting.
It's
Only
melting.
only where I put the salt.
Only where you put the salt, because what is the salt trying to do with the ice?
It melts it.
It melts it. It's also dissolving in the water. So the more salt that dissolves in the water is changing how much energy it takes for the ice to get frozen. Right? So that's why if you go to like Boston or New York and there's a huge snowstorm and they need to clear the roads, they take a large, big thing of salt, put it on the road, on the ice, make the ice get more liquidy, and then clear it away. And they're using chemistry, the knowledge of chemistry, to do that. So I challenge all of you to try this little experiment with the water sugar water and salt water. It's very interesting. For the first hour, the first time you checked it after 1 hour, you will see nothing's really frozen yet. The next hour, you will see one of them is frozen. You're going to find out which one. And then maybe check every half an hour after that. You will see another one freezes, and you'll have to figure out which one freezes first, the sugar one or the salt one. And then who freezes last. It'll be interesting for you guys to note that. It's super easy to do. Definitely use a plastic cup. Don't fill the cups all the way to the top. And add 4 tablespoons of sugar and 4 tablespoons of salt in the other one. Definitely label your cups so you don't forget which one is which. Okay? Yes.
We don't have any disposable cups.
I'm sure your mom and dad can help you with that some other time. Just want a plastic cup. You don't want to do it in a glass cup because you might shatter the cup if it goes in the freezer. Okay, definitely a plastic cup. Want to say that. Okay. We're almost out of time. Does anybody have any questions? Anybody have any questions? Guy, do you have a question?
I think we probably have to do the experiment tomorrow since it's like 7.
Yeah, that's what I was saying. Don't do it tonight. You don't have time to sit up and do all these like observations this late at night. You can start it tomorrow when you guys get out of school. Maybe like whenever, like at 3 o'clock or something, you get home, make your cups of water, put it in the freezer. 4 o'clock, go check it. 5 o'clock, go check it. Maybe 5:30, check it again. 6 o'clock, 6:30, check it again. You will notice there are differences. I could watch the video with you to show you the differences, but I'd rather you figure it out yourself. So I stopped it before she said anything. So because there are differences between the sugar cup and the water cup and the regular cup, and it's really cool. I want to challenge you to get this done yourself, okay? And then if you have no more questions, you guys.
Take our 3 cups.
Next time we meet is on April 15th. I'll see you next month, okay? I hope you guys had a good time and thank you for coming, okay?
Thank you.
See you
Guy,
next time.
Guy,
Bye-bye.
Guy.
No.
Oh,
Bye-bye.
I'd like.
I forgot what call what's the on Facebook.
Leslie, just log on to Discord so you can talk to me.
Bye now.
Bye.
Bye. Bye, Thiago. Bye-bye.